We can now continue with discussing another option, which is mapping an EER model to a relational model. Here you can see the ER model which we covered earlier. In what follows, we will discuss how to map this to a relational model. Let's again start by briefly revisiting the key concepts of a relational model. A relational model consists out of relations. A relation is a set of tuples characterized by attributes. It has a primary key which uniquely identifies its tuples. Relationships can be established by means of foreign keys, which typically refer to primary keys. We will assume that all relations are normalized, such that no ambiguities or redundancies are left in the model. The first step is to map each entity type into a relation. Simple attribute types can be directly mapped. A composite attribute type needs to be decomposed into its component attributes. One of the key attribute types of the entity type can be set as the primary key of the relation. You can see this illustrated here. We have two entity types, employee and project. We create relations for both. The employee entity type has three attribute types: Social Security number, which is the key attribute type; address, which is considered as an atomic attribute type; and e-name, which is a composite attribute type consisting out of first name and last name. The project entity type also has three attribute types: project number, which is the key attribute type; project name; and project duration. You can see that both key attribute types, Social Security number and project number, have been mapped to the primary keys of both relations. Also note that the e-name composite attribute type has been decomposed into first name and last name in the relation employee. Once we have mapped the entity types, we can continue with the relationship types. We create two relations for each entity type participating in a binary one-to-one relationship type. The connection can be made by including a foreign key in one of the relations to the primary key of the other. In case of existence dependency, we put the foreign key in the existent dependent relation and declare it as not null. The attributes of the one-to-one relationship type can then be added to the relation with the foreign key. Let's consider the manager's relationship type between employee and department. Remember, an employee manages either 0 or 1 department, whereas a department is managed by exactly 1 employee. In other words, department is existent dependent from employee. We create relations for both entity types and add the corresponding attribute types. The question now is how to map the relationship type. The first option would be to add a foreign key d-number to the employee relation, which refers to the primary key d-number in department. Obviously, this foreign key can be null, since not every employee manages a department. Let's now find out how many of the 4 cardinalities of the relationship type are correctly modeled. We start from department. Can a department have 0 managers? Yes, this is the case for department number 2, the call center, which has no manager assigned. Can a department have more than 1 manager? Yes, this is the case for department number 1, marketing, which has 2 managers, employee 511, John Smith, and employee 564, Sarah Adams. Can an employee manage 0 departments? Yes, this is the case for Emma Lucas and Michael Johnson. Can an employee manage more than one department? No, since the employee relation is normalized, and the foreign key department number should thus be single valued. To summarize, out of the 4 cardinalities, only 2 are supported. Moreover, this option will generate a lot of null values for the department number foreign key, as there are typically many employees who are not managing any department. Another option would be to include Social Security number as a foreign key in department, referring to Social Security number in employee. This foreign key should be declared as not null, since every department should have exactly one manager. Let's now also look at the other cardinalities. Can you have employees that manage 0 departments? Yes, this is the case for Emma Lucas. Can we make sure that an employee manages at most 1 department? In fact, we cannot. As you can see, John Smith manages 3 departments. Hence, out of the 4 cardinalities, 3 are supported. This option is to be preferred above the previous one, although it is clearly also not perfect. The semantics lost in the mapping should be documented. Binary 1 to N relationship types can be mapped by including a foreign key in the relation corresponding to the participating entity type at the N side of the relationship type. The foreign key refers to the primary key of the relation corresponding to the entity type at the 1 side of the relationship type. Depending upon the minimum cardinality, the foreign key can be declared as not null or null allowed. The attribute types of the 1 to N relationship type can be added to the relation corresponding to the participating entity type. The works in relationship type is an example of a 1 to N relationship type. An employee works in exactly 1 department, whereas a department can have 1 to N employees working in it. The attribute type starting date represents the date at which an employee started working in a department. As previously, we first create the relations employee and department for both entity types. We can again explore 2 options to establish the relationship type in the relational model. Since a department can have multiple employees, we cannot add a foreign key to it, as this would create a multivalued attribute type. That's why we add department number as a foreign key to the employee relation. Since the minimum cardinality is 1, this foreign key is defined as not null. We hereby correctly ensure that an employee works in exactly 1 department. What about the other cardinalities? Can a department have more than 1 employee? Yes. This is the case for the marketing department, which has 2 employees, John Smith and Paul Barker. Can we guarantee that every department has at least 1 employee? In fact, we cannot. The finance department has no employees working in it. Out of the 4 cardinalities, 3 are supported. Note that the attribute type starting date has also been added to the employee relation. M to N relationship types are mapped by introducing a new relation R. The primary key of R is a combination of foreign keys referring to the primary keys of the relations corresponding to the participating entity types. The attribute types of the M to N relationship type can also be added to R. The works on relationship type is an example of an M to N relationship type. An employee works on 0 to N projects, whereas a project is being worked on by 0 to M employees. We start by creating relations for both entity types. We cannot add a foreign key to the employee relation, as this would give us a multivalued attribute type, since an employee can work on multiple projects. Likewise, we cannot add a foreign key to the project relation as a project is being worked on by multiple employees. In other words, we need to create a new relation to map the ER relationship type works on. Here you can see the relation works on defined. It has two foreign keys, social security number and project number, which together make up the primary key and can thus not be null. The hours attribute type is also added to this relation. Here you can see some example tuples. All four cardinalities are successfully modeled. Emma Lucas does not work on any projects, whereas Paul Barker works on two projects. Vice versa, projects 1002 and 1004 have no employees assigned, whereas project 1001 has 2 employees assigned. Now let's see what happens if we change the assumptions as follows. An employee works on at least one project, and a project is being worked on by at least one employee. In other words, the minimum cardinalities change to 1 on both sides. Essentially, the solution remains the same, and you can see that none of the minimum cardinalities are supported, since Emma Lucas is not working on any projects, and projects 1002 and 1004 have no employees assigned. Out of the 4 cardinalities, only 2 are supported. This will require close follow-up during application development. For each multivalued attribute type, we create a new relation R. We put the multivalued attribute type in R together with a foreign key referring to the primary key of the original relation. Multivalued composite attribute types are again decomposed into their components. The primary key can then be set based upon the assumptions. Let's say we have a multivalued attribute type phone number. An employee can have multiple phones. We created a new relation mPhone. It has 2 attribute types, phone number and social security number. The latter is a foreign key referring to the employee relation. If we assume that each phone number is assigned to only one employee, then the attribute type phone number suffices as primary key of the relation mPhone. Let's now change the assumption such that a phone number can be shared by multiple employees. Hence, phone number is no longer appropriate as primary key of the relation. Also, social security number cannot be assigned as primary key, since an employee can have multiple phone numbers. Hence, the primary key becomes a combination of both phone number and social security number. This example clearly illustrates how the business specifics can help define the primary key of a relation. A weak entity type should be mapped into relation R with corresponding attributes. A foreign key must be added referring to the primary key of the relation corresponding to the owner entity type. Because of the existence dependence, the foreign key is declared as not null. The primary key of R is then the combination of the partial key and the foreign key. Here you can see our earlier example. Room is a weak entity type which is existent dependent from hotel. We created 2 relations, hotel and room. Room has a foreign key, hotel number, which is declared as not null and refers to hotel. Its primary key is the combination of room number and hotel number. Here you can see some example tuples. can be clearly seen that all four cardinalities are nicely supported by the relational model. To map an N-ary relationship type, we first create relations for each participating entity type. We then also define one additional relation R to represent the N-ary relationship type and add foreign keys referring to the primary keys of each of the relations corresponding to the participating entity types. The primary key of R is the combination of all foreign keys, which are obviously all not null. Any attribute type of the N-ary relationship type can also be added to R. The relationship type booking is a ternary relationship type between tourist, booking, and travel agency. It has one attribute type, price. The relational model has relations for each of the three entity types together with a relation booking for the relationship type. The primary key of the latter is the combination of the three foreign keys, as you can see illustrated. It also includes the price attribute. All six cardinalities are perfectly represented in the relational model. The relationship type offers is a ternary relationship type between instructor, course, and semester. An instructor offers a course during 0 to n semesters. During a semester, a course should be offered by at least one, at most one instructors. During a semester, an instructor can offer 0 to n courses. As with the previous example, the relational model has one relation per entity type and one relation for the relationship type. Let's now have a look at the cardinalities. Here you can see some example tuples. Note that the course number 110, Analytics, is not offered during any semester. Some other courses are not offered in all semesters. Hence, the minimum cardinality of 1, stating that during a semester a course should be offered by at least one instructor, cannot be guaranteed by the relational model. N-ary or recursive relationship types can be mapped depending upon the cardinality. A recursive one-to-one or one-to-n relationship type can be implemented by adding a foreign key referring to the primary key of the same relation. For an n-to-m recursive relationship type, a new relation R needs to be created with two not null foreign keys referring to the original relation. It is recommended to use role names to clarify the meaning of the foreign keys. Here you can see a one-to-one N-ary relationship type modeling the supervision relationships between employees. It can be implemented in the relational model by adding a foreign key supervisor to the employee relation, which refers to its primary key social security number. The foreign key can be null, since according to the R model, it is possible that an employee is supervised by 0 other employees. Since the foreign key cannot be multivalued, an employee cannot be supervised by more than one other employee. Some employees do not supervise other employees, like Emma Lucas. However, some employees supervise more than one other employee, like Paul Barker, who supervises both John Smith and Emma Lucas. To summarize, out of the 4 cardinalities, 3 are supported by our model. Let's now change one assumption as follows. An employee can supervise at least 0, at most n other employees. The relational model stays the same, with supervisor as foreign key referring to social security number. In this case, all 4 cardinalities can be perfectly captured by our relational model. Let's now set both maximum cardinalities to n and m respectively. In other words, An employee can supervise 0 to n employees, whereas an employee can be supervised by 0 to m employees. We can no longer add a foreign key to the employee relation, as this would result into a multivalued attribute type. Hence, we need to create a new relation, supervision, with two foreign keys, supervisor and supervisee, which both refer to social security number in employee. Since both foreign keys make up the primary key, they cannot be null. All four cardinalities are perfectly supported. Note, however, that if one of the minimum cardinalities would have been 1, then a relational model could not accommodate this. We can now conclude the discussion of the steps that should be followed when mapping an ER model to a relational model. This table summarizes how the key concepts of both models are related. Here you can see the resulting relational model for our employee administration. Let's briefly discuss it. The primary key of the employee relation is social security number. It has two foreign keys. Manager number refers to social security number and implements the recursive supervised relationship, and department number, which refers to department and implements the works in relationship. The former is null allowed, whereas the latter is not. The primary key of department is department number. It has one foreign key, manager number, which refers to social security number in employee and implements the manager's relationship. It cannot be null. The primary key of project is project number. The foreign key department number refers to department. It implements the in charge of relationship and cannot be null. The works on relation is needed to implement the M to N relationship type between employee and project. Its primary key is made up of two foreign keys referring to employee and project respectively. It also includes a relationship type attribute hours, representing how many hours an employee worked on a project. As we already mentioned, a relational model is not a perfect mapping of our ER model. Some of the cardinalities have not been perfectly translated. More specifically, we cannot guarantee that a department has at minimum one employee, not considering the manager. Another example is that the same employee can be manager of multiple departments. Some of the earlier mentioned shortcomings for the ER model still apply here as well. We cannot guarantee that a manager of a department We cannot guarantee that a manager of a department also works in the department. We can also not enforce that employees should work on projects assigned to departments to which they belong.